So, last class we talked about our last type of parallelogram, rhombus and squares. Those were our special parallelograms. We had rectangles, rhombuses, squares, RRS. That homework was due right now. Make sure that you turn that homework in and check this key that should be posted on Schoology in today's folder. After you watch this video, you will complete the trapezoid practice worksheet and submit that on Schoology. After that, you can do the trapezoid homework, pick the odd problems or the even problems. You do not need to do all of the problems. And then there's a delta math. That's extra practice for our quiz that's coming up on Monday. So, at this point, we've looked at all types of parallelograms, rectangles, rhombi, and squares. Those are three types of special parallelograms. We will now investigate a different type of quadrilateral, a trapezoid. A trapezoid is a quadrilateral with only one pair of parallel sides. We call these parallel sides the bases. And you can obviously see from this picture here, AD and BC would be considered the bases because those two are the parallel sides. The other two sides of a trapezoid are called the legs. These are the non-parallel sides. As we can clearly see, AB and DC are not parallel. If you continue the lines on and on, they intersect. They are not parallel. Those are called our legs. Right now, I'd like you to take a second and in your notes, identify which two sides are the bases and which two sides are the legs for the following trapezoids. Okay, in the first example, the two sides that are parallel, those are our bases. The other two sides, well, they have to be our legs. Next example, I rotated the trapezoid on you. It doesn't always need to be the top and the bottom, right? The top and the bottom, in this case, will intersect. Those are our legs. The two parallel sides, those are our bases. Then the last example, two parallel sides are pretty obvious. Other two sides are our legs. The first property that we have about trapezoids is that their adjacent angles are supplementary. We will locate these adjacent angles. The adjacent angles are not the two angles that have the same base. Those are not adjacent angles. We call those base angles. Adjacent angles in a trapezoid are the two angles that are formed looking at the two different bases. All right, so the angles that are next to each other but do not have the same base. If they have the same base, we call those base angles. Again, there's no relationship between the base angles, not in a general trapezoid. In the same pictures from above, please take a second now to identify which two pairs of angles are going to be supplementary. In the first example, we have that angle and that angle. Those are supplementary angles. Those are adjacent angles. Right? Again, it's not the two angles that have the same base. Those are base angles. Those are our two pairs of supplementary angles. Next example, those are two pairs of supplementary angles. In our last example, we have those two pairs of supplementary angles. So what's important for us to do when we're trying to identify that is to actually figure out where the bases are, right? And you know that the adjacent angles that you're looking at cannot both be on the same base. Identify the bases first, then we can identify where our adjacent angles are going to be. An isosceles trapezoid is a special type of trapezoid, right? So at that point, this is pretty much everything we know about a general trapezoid, except for its mid-segment, and we're going to talk about that later. These are the properties of trapezoids. An isosceles trapezoid is a special trapezoid defined by the following. A trapezoid is isosceles if the non-parallel sides, which we call the legs, are congruent. A trapezoid is isosceles if the base angles are congruent. That applies to both pairs of base angles. Right? In any trapezoid, you have two bases, you're going to have two pairs of base angles. In an isosceles trapezoid, those base angles are going to be congruent. And the last one that we have is that a trapezoid is isosceles if the diagonals are congruent. Those are our three rules that are going to make a trapezoid an isosceles trapezoid. So we'll go through, mark all the congruent parts that will make this trapezoid an isosceles trapezoid. And then there's the one on the right that I'll have you do. In order for this trapezoid to be an isosceles trapezoid, the non-parallel sides, the legs, have to be congruent. If I know this much, that those are my bases, those are parallel lines, and the legs are congruent, that's enough to say that this is isosceles. In a trapezoid, if I know that the base angles are congruent, so maybe we'll call that X, and we'll call these angles Y. If my base angles are congruent, obviously my other pair is going to be congruent as well because they're still supplementary, right? So X and Y are still supplementary. This is enough to say that this trapezoid is isosceles. And the last one that we have, in a trapezoid, if the diagonals of my trapezoid are congruent, so if these are the same length, then that is enough to say that this is an isosceles trapezoid. Take a second right now and do the same with the example that is on the right. Here's everything that we need. First off, the fact that this is a trapezoid, that those two sides are parallel, those will be our bases. Then, if the non-parallel sides are congruent, that's enough to call this isosceles. If the base angles are congruent, if the base angles are congruent, that's enough to say that this is isosceles. If the diagonals are congruent, that's enough to say that this is isosceles. Moving on to these examples that we have. First example, I want you to think of right now, is this just a trapezoid or is this an isosceles trapezoid? Good. It's an isosceles trapezoid because the non-parallel sides, A, B, and C, D, are congruent. Our legs are congruent. Measure of angle B. I'm only given angle A. I can find every other angle in this picture just by giving angle A. I'm looking for angle B. I know that in any trapezoid, the adjacent angles, again, not the base angles, but the adjacent angles are supplementary. So I know that angle B is 123 because it's supplementary to angle A. Well, now that I know that angle B is 123, I can find angle C, which is also 123 because it has to be congruent. Because in an isosceles trapezoid, the base angles are congruent, which leads me into D. If A is 57, D is also 57. It's congruent to angle A. Now I want you to think, for the next example, is this a general trapezoid or is this an isosceles trapezoid? Not an isosceles trapezoid. How do you know that? Well, FE and GD doesn't tell me that they're congruent. Here is my base. Those two angles are not congruent, so my base angles are congruent. And I don't know anything about the diagonals, so not enough to say that that's an isosceles trapezoid. Measure of angle D. I know angle G is 67. I know that angle G and angle D have to be supplementary. Angle D is 113. Again, adjacent angles, not the base angles. They are supplementary. Same thing with finding the measure of angle E. If angle F is 83, angle E plus angle F has to sum to 180, which means that angle E is 97 degrees. The biggest mistake that I'll see is in a general trapezoid. You'll try and say, well, angle F is 83, angle E's got to be 83. Angle G is 67, angle D has to be 67. That's only the case if we have an isosceles trapezoid. And the last example we have, I'd like you to try, so please take a second, pause the video, give that one a try. Oh,
just a reminder to all ESP, please bring a device and head to the library for 7:30 professional development. All ESP, please bring your iPad or laptop and make your way to the library for PD.
All right, well, sorry for that announcement, but I didn't feel like re-recording this video. So, all right, next example. We know that that is an isosceles trapezoid because the non-parallel sides, JK, ML, are congruent. Measure of angle J, that's going to be supplementary to angle K, 80 degrees. Measure of angle L is going to be congruent to the measure of angle K, and the measure of angle M is going to be congruent to the measure of angle J. The next thing that we're going to talk about is the mid-segment or median. You'll see both of those kind of used interchangeably. The mid-segment or median of a trapezoid is the segment that connects the midpoints of each leg. So here my leg is AD, my leg is BC. The mid-segment is going to connect the midpoint of each of those. Midpoint of AD is M, midpoint of BC is N. There's my mid-segment. The mid-segment is parallel to each base. Here's AB, here's DC. MN, my mid-segment, is parallel to them. The measure of the mid-segment is the average length of the bases. The average length of the bases. In this problem, MN is equal to AB plus DC divided by 2. That's how we find the average. Add them up, divide by 2. That's how we find the mid-segment. For example 1, set it up exactly how we should. Mid-segment, MN, which I'm going to call X, is equal to one of the bases plus the other base divided by 2. 12 plus 28 divided by 2. 12 plus 28 is 40. 40 divided by 2 is 20. we get that the length of that midsegment is 20. Again, just the average of the two bases. This next example, I want you to think for a second. Am I actually looking for the midsegment of this trapezoid? No, I'm looking for the length of one of the bases. I already know that the midsegment is 23. So I have 23 is equal to x plus 27 divided by 2. Midsegment, 23, is equal to x plus 27 divided by 2. I want you to take a second to think about how you would solve this algebraically. Your first step is going to be multiplying both sides by 2. Right? You have x plus 27 divided by 2. You've got to get that x by itself. In order to do that, got to get rid of that 2. So we multiply both sides by 2. You have 46 is equal to x plus 27. Subtract 27 from both sides, and you get x is equal to 19. Oh, there's a jump scare if you were wanting one. All right, problems 3 through 6. We just want to find the value of x using our midsegment. Right now, I want you to give problems 3 and 4 a try. Pause this video right now and go ahead. Problem 3. We are looking for the midsegment. Midsegment is equal to 19 plus 31 divided by 2. Problem 4. We're looking for one of the bases. We know that the midsegment is 34. 34 is equal to x plus 43 divided by 2. Solve for x. Problem 5 and 6 add a little more to this, but we can still solve it the same way. We know that the midsegment is 7. We know that one of our bases is 2x and one of our bases is 10. 7 is equal to 2x plus 10 divided by 2. Multiply both sides by 2 to try and get 2x by itself. Subtract 10 over, divide by 2. You get that x is equal to 2. And for our last one, I want you to try and set it up same way that we have with all of our midsegment. Midsegment is 18.7. One of our bases is 5x. One of our bases is 12x minus 1.7. 18.7 is equal to 5x plus 12x minus 1.7 divided by 2. Multiply both sides by 2. 37.4 is equal to 17 minus 1.7x. 17x minus 1.7. Add 1.7 to both sides, divide by 17, you get x is equal to 2.3. Now, I know some of you might be thinking, if you were to do this on the homework, or if you were to do this on a quiz or a test, I don't think that 2.3 is the right answer. Okay, well then check. Substitute 2.3 in for x and see, is it true? 5 times 2.3 plus 12 times 2.3 minus 1.7 divided by 2. Does that actually get you 18.7? If it does, great. If it doesn't, you made a mistake somewhere and you can go back and adjust your work. Right now, complete the trapezoid practice worksheet both pages, and make sure you submit that to Schoology. After you do that, complete the trapezoid homework, pick odds or evens. And if you have any questions, please feel free to email me and let me know. There is a Delta Math available. Please use that as extra practice, because next class, we have a quiz on naming quadrilaterals. So similar to the RRS homework, at least the start of it, where you're given a figure and you need to determine what is the most specific name you can give that figure. Have a great rest of your day. I will see you all next week.